Hello. So today we're gonna work on some more player controller stuff. Um, um, since our we got left off with this player controller where we can at least turn the camera. I would like to play around with the mouse. As you can see, I'm allowed to extend the mouse, and that means we're kind of getting some problems here. So we need to every frame force the mouse to the center of this, or rather grab the input, then recenter the mouse on the center of the screen. I actually have some code here that calculates the center of the screen, not screen, um, which we could play around with. Let's see. Let's play around with that. Uh, simply use that, and then set mouse position Win32 API. Set cursor position. Let's try that. Center X, center Y. Let's try that. Yeah. The problem with our code is now that we kinda we get the change. Yeah, we calculate the handle. Stores the point. Maybe if we actually calculate all this stuff up here. Then we have the center. Let's try. Let's comment this out and redefine it, and let's use this for now. Now we just keep spinning. If we do not clamp it, yeah. Yeah, we want some change. What if we store the delta x from last time and subtract that instead? So yeah. Let's not do the actual yaw. Let's just simulate some values here. Calculated center x test value, and we want to subtract center x by the x point of the mouse. Well, it's probably going to need to be in screen space. Because we still force the mouse. Let's see. That's the absolute center, or window center absolute. There we go. But then we have our screen coordinates here. Let's see. Oh well. Yeah, so we have our absolute position. I think screen to client is yeah, so that is let's see if we do another version. Client to screen. Let's see, let's store that old one and change the assigning of the value client to screen. Let's see. let's see. Just print it out so that we mouse X screen center. Our console got hidden. I mean, is this actually the center of the screen? No, it's not. I think it's bound to the console, or rather, no, it gets bound to whatever we're pointing at. So let me just move the console here. Oh, of course I need to be able to set this on and off. Let's do an internal flag here. Flag log mouse false. Get async key state f vk f maybe 6. Is that available? I think so. And F7 set to false, just so that we can toggle this. If flag lock mouse, we will do it, otherwise we won't. So now I can move my mouse. Then if I press F6, yeah, F5, F6. Oh, did I not change? Let's see. I mean, it still doesn't work. Oh, it's F7. Let me see inside our application what F buttons are used. 4, yeah, we will skip 5 then. Yeah, that works. Great. So the mouse X should be somewhat close to the center of the screen, which is not. Let's see. Do we client to screen? Client. Yeah. Screen position of mouse, Win32. I'll get the cursor position. Simply if we do not do any manipulation here. Yeah, and if we do F6, yeah. Yeah, that's great. That's what we need. Let's move this down to here. And what difference do we get whenever we, let's see, we press F6, minus, plus, minus, plus, minus, plus. Let's see, hide mouse cursor. Show cursor. Let's see, false and true. It's just this. Yeah, so we do not get any. So F6. Yeah, now we can scale everything. Let's see. And what, oops, I would actually like the debugging information. What sign will it get when I try to, let's see. When I move to the right, it's negative. Let's swap these then. There we go. And then we want to clamp it, and then we want some time step here. F6. Great stuff. Oh my goodness. Would you look at that? Would you look at that? It's beautiful. It's beautiful. And we could do a tiny bit of pitch as well. Let's see. We clamp it very low. And move this down to here. And we swap that. Wait a minute. Let's just replace that. Remove that. Dump that down here. Disable that. And then we would like only to do this, not to get motion sickness if our mouse is locked. So let's see. Well, it's definitely pitching. Yeah, but maybe it's not what I want. Let's see, what is the pitch actually doing, because yeah, we calculate a rotation matrix around the so it's supposed to be the set the right as well. Let's see. Well, we're not getting. Yeah, we're getting some weird results. This works for our free floating camera the way we want it, but maybe we want something else in terms of vertical look. So the vertical look is going to be, let me see, let me just disable the pitch. Leave it there for now. So right now we are taking the up axis. And we want to be changing the up axis by rotating it around whatever is our right side. Let's see, vertical look, load, angle. Let's see, we want to get a rotation matrix around our right hand side angle, and we want to update the upwards going vector, but our forward going vector is also going to be needed to get updated. Let's just start with this. It's not gonna work, but I just would like to see the effect. So yeah, right now we're kind of which is maybe maybe we only want to transform. Hello, welcome. So we apply the rotation matrix to, yeah, that's more like it. It's not entirely accurate. As you can see, it kind of just does a somewhat. Thank you. I've been working on it for some time now. I also added physics. Let's try to rotate both the axes here. No, that's not good. It's not that hard. Once you uh, um, get into it. As you can see here, I can add rotation physics to the object. I'm not pushing any buttons. This is just the physics engine that simulates rotation on the object for every frame. I could also do, let me see, I know F5 is available. So let's add forces, and we will add some jump to it. So we go upwards the y-axis, and then I will set the physics system down here to do a bit of bounciness on the object whenever it collides with the ground. Let me see, I set it here. Yeah, we want to bounce a lot. So let's see. I'm just gonna swap to a different camera. I think the free floating camera here is better. Let's see. Whoops. Okay, I missed it. Missed the camera. I changed some controls here. Let me see. So if I push the F5 button, we lift off, and now it comes down by gravity. I'm not pushing anything, and as you can see, it bounces off the ground. We could make it even more bouncy if we wanted to. Let's see. Get the free floating camera here. And let's see what I added that button. I'm gonna add some rotation to it as well. And then we will see it drop down eventually whenever gravity, as you can see. Yeah, right now I'm gonna implement some OBBs and a sphere later on. So I already implemented the sphere mathematically, but I haven't done collision checking. This is actually, the blue one here is a sphere, but I haven't changed the renderer to actually draw a sphere instead of a box. So this is just this radius, and you can imagine the sphere being not including these corners here. But yeah, I started out doing AABBs, then I'll do OBBs for when this rotates, it needs to update the bounding volume and of course rotate that as well. But I haven't implemented that yet. I'm doing a player controller here, as you might. Let's see. Um, I changed the camera here, and I want a camera that is able to lock the mouse and yeah, do whatever I need so that I can in my player controller here calculate some movement. Let's see. Yeah, this feels better. I still think we might have too much speed on the uh, the uh, the yaw. Let's see. I don't know if this is inverted mouse. No, it's fine. Yeah, there's definitely some weird stuff going on whenever the vectors aren't getting calculated correctly. Yeah, I think I need to redo this. I think I need to redo this. Because if I do like this, you can see everything gets wobbly. It's weird. Yeah, so I need to look into the actual computation of the rotation. We want probably to maybe rotate these axes individually. Let's see. Is that better? No, now we end up with not having any. Maybe if we swap these. And it doesn't really move in that direction. Well, yes, I'm not calculating the vectors correctly here. Um, we'll swap it back to the old solution and look into what actually is going wrong. Perhaps we could do some debugging in terms of drawing the coordinate system of the camera. Later on, because we can always swap to our free floating camera here and check whatever check whatever we also want to reset this camera lock whenever we swap to the first camera or second camera, and then only use this for the player camera, meaning for instance, if I enable the player camera here, which is really weirding me out. If I swap and then I swap back and then I enable the thing again. Yeah, let's see, yeah. Let's look. You might get dizzy. I'm sorry. Maybe we want some more angular dampening on the rotation forces, at least for now. Let's just reduce it by 20%. Okay. Oh, at least we're getting somewhere. I'm unsure whether I should use more time on this. If we're only rotating the forward-going axis. Yeah, we end up with something fairly weird. I think this is better. Anyway, maybe if we only transform the upward going. No. I mean, the rotation isn't right. I think we need another rotation here. Maybe if we're rotating by another axis. Well, no. So let's draw it out. What we're trying to do here, sorry for any screen flashes. Doesn't fill. We don't like black dots. So if we have our Y, we have our X, which is going to be, let's see, in our coordinate system, it's like that. And then we have the C, which is going like that. Our camera here, player camera, gets initialized as something that has the x-axis as a right. It's looking outwards in terms of negative c, meaning that it's kind of looking in this direction. Can't really draw it. And y is up. So whenever we want to pitch, we would like to be able to rotate over the x-axis. But what happens if the whole thing shifts? Yeah, maybe it's the way I calculate the matrix that does the rotation. Yeah, maybe I just want to pass in a quaternion instead and do Euler angles after that. So the original pitch here. So the pitch is used in the free floating camera. So if I swap to the free floating camera and enable the free floating control of the camera, as you can see, everything actually works as intended. I am able to control the camera by using pitch and yaw as they're implemented, and nothing looks weird. I mean, the camera doesn't skew around. I know the movement is jittery, but you could always interpolate the movement. Let's see. Let's see. So yeah, it's not the pitch itself. Let's see. Yeah, I think we need to look into the camera stuff eventually. Maybe we only want to manipulate the up axis during some vertical looking. No. Well, it definitely chooses the wrong angle, I think. Maybe if we take the forward going. Let's see. Maybe if we because right now, yeah, that kind of made it. So right now we're rotating the upwards axis around. You wrong. Negate. That's because no. We're rotating around the wrong axis here. I mean, I'm pushing the mouse up and down and it tilts to these sides instead of maybe instead of negating that. I'm sorry, I'm gonna play around with the camera a bit here. Maybe we want to calculate the axis first. We want to, whenever we rotate around the Y, we would always want to let's just print it. Do I have somewhere where I dump the matrix? I think I do. Let's just use the old one instead of the macro. Right vector. Let's see. And let's move this off screen. So yeah, this is going to be, well, it's not normalized. I think at least. Is it? So yeah, this way. Let's see. For some reason, up vector, forward vector. Let's just dump them during this because it will be easier to debug whenever we know what the vectors look like. So the up vector is still correct. This means that we're currently looking forward For some reason, the right component, the right vector has another component. Let me just see. During initialization, do we recalculate the... If I disable the... Maybe I do something stupid here. Let's see. Maybe I do something stupid when I calculate the yaw. Let's see. So the right vector, no, it still is set to 1. Let's see in our application. Oh my god. This is why nothing is working as intended. So let's see. Let me just disable this, move this off screen. Then our right vector is behaving correctly. Yeah, this might just fix it. Stupid bug. Let's see, let's just use the pitch. And everything works. Oh my god, it was just a bug. Great that we actually tried to debug it. Let's see, we don't need this anymore. And we remove it from the system here. Great stuff. Yeah, always debug your information. Sometimes you might have mistyped something. All right, finally. So now we have a camera. Let's see, inverted mouse. Does it feel natural? No, it's inverted mouse. I don't like that. Let's clamp this a bit more. That's a bit too slow. This might be a bit too fast. And this might be a bit too slow. Let's see. Yeah, maybe I want it fairly slow. Maybe even a bit slower. Yeah, now the yaw feels a bit too fast. compared to the, well, this is somewhat slow as well. Maybe we do the 2.5 here. That is a bit too fast, actually. Maybe just 2. Did I? No, I didn't. It just felt weird. Yeah. Maybe we want a broader field of view also. Not that broad. Yeah, we could do some smoothing. Anyway, fine tuning is not a high priority. So yeah, if we got a locked mouse, or so yeah, if we set the actual camera to our player, we do like that. For some reason it didn't hide the mouse. I have to do it again. Anyway, we're golden. So time for some movement stuff. Cursor handling, clamp it. So a player controller might have a, let's see, do we have any specific game objects here? No, we do not. Outside the player folder, we have some game object data. Objects transform. Transform. We'd want to store our position, our, maybe not, scale and rotation for now. We also want to move this outside. Separate struct. But right now we have our transform data. We want our onCreate to set our position to something. Our application. We start the position here. Let's see. We could just do a G vector position, start position, and pass that in. Start position. It's a float. Okay, G float 3. Our application will need to pass in what is our player start position. That's not it, that's the physics component. And we want to pass in that. Let's see. So we could just clamp it. Oh, I picked the wrong value. No need to clamp it. There we go. So we load in our play position. We handle the camera offset outside this. We could do yeah, we set our start position here. Does our camera have methods for that? Update position. Could we cast it? We could. Oh yeah, then we can float camera camera Y offset, and right now we do down here the thing called that. Then it's we set our camera update position, and we pass in our start position.y plus m camera offset, and then start position.c. and just 00F. This shouldn't change anything. But right now we could simply just leave this uninitialized, I think. Let's try that. Actually, just uninitialize it. Yeah, everything works. Yeah, we definitely want some camera smoothing. Let's do a position, set by player controller. Great stuff. Which means that wherever we spawn our player, we will make the camera follow, and we can, inside the player controller, actually adjust how to offset the camera, which feels nice since it's part of what to do in terms of do in terms of yeah. Anyway, then we're not gonna do collision right now. We will save that for later. We will do some basic movement. Let's do some private methods here. Void calculate forward vector. Um, uh, and we will save a G vector. Camera coordinate forward. which will be initialized as 0. And on create, we will set this to the camera forward going vector. And we will store that since we will handle, and this is the local space. This is camera stuff, initialize camera information. This is set up information to transform between world and local space. Then we want a method that is calculate the forward going vector. We will try to get the forward going vector in terms of the player camera, in terms of the X and C axis. Wait a minute. So yeah, we have our camera coordinate system right now. Y is pointing forward. X is pointing to the right. C is pointing down to the ground. We want something strictly forward, meaning that we want something in only the X and C plane. Yeah, so we can use the dot product in terms of projecting. Right now, forward would be parallel with the x-axis. Let's see, cross product vectors. Yeah, so maybe let's just test this G vector. We're gonna call this every frame up equal to camera get forward. So I do not have a method that allows me to get forward align G vector get up program up align G vector get right. Test forward. Let's try right, real up, and dump the temporary calculator. Let's just copy some of this forward vector, and let's just, for the sake of completeness, add less component here. Yeah, so the forward vector is positive C, which is not correct. This is definitely not correct. But let's see. So minus, yeah, it's correct, except that we have to negate. And then, of course, we would like to normalize it. Not that I think it's going to be a problem since the others will be normalized. Maybe it does need to be normalized. So this is, yeah, it did need to be normalized. Let's see. I'm just gonna move this up here and move this down here and then enable the player camera again. I think, no, it didn't need to be normalized, I think. It didn't matter, as the others are always normalized. Let's see, so yeah, this doesn't affect the forward going vector. Only when I do slight rotations. I mean, yeah. So this calculates our forward-going vector. Right now it would be positive C only. This will be negative X only. Yeah. Time to wrap this into something. M camera coordinate forward. Let's just, instead of calling it that, M forward vector. Oh, whoa. Wait a minute. Yeah, we don't need to use that value actually, because we can just set the yeah, we can create a new coordinate system where we get the right vector of the camera even though it's rotated to oblivion, and then we just say that we want that as the right-going vector of the coordinate system, but we want a vector that points up uh, uh, wherever we are as our y vector, and then we want something that is perpendicular to those two axes, which is the cross product of the right-going vector and the coordinate system upwards going vector, and therefore we get the forward-going vector no matter how the camera is rotated. So let's store that in our forward-going vector. This means that if we were to add motion, we would always have a vector that points directly forward, no matter how we position our camera. Even if we are looking at the ground, we will be knowing that we should go in a forward going motion, and the vector therefore is independent of camera rotation on the, in terms of the over the x-axis, but it of course is entirely dependent on the yaw of the camera. All right, now we have a direction vector that we can use in our world to, let's see, we could actually call this calculate world forward going vector, because it's actually relative to, or maybe we just want it like that, because it's actually the vector in terms of world space. It's not in terms of the local space of the player, which we kind of already welcome to the channel, Mikhail. I hope I pronounced that correctly. I'm sorry if I butchered it. Yeah, so now we can do some motion stuff. Let's see, I'm gonna branch this so that we can close it as it pertains the input system, which is not implemented. Input related stuff. And we can just close it. So yeah, we want to implement these next three steps. We want something. We will start out with a private function. Maybe we will change it. Move vertical, let's just call it that. We want a float amount and then a float time step. And we want to bind it to move. Let's see, what did I call it? I called it move vertical. And let's just try 20 and then our time step. And then move vertical. Let's do the opposite here. So whenever we press W or S, we proc this function. Right now, our camera is kind of like the only thing that we can move. So we want to just take our camera, update the position, which will be some math vector, add scaled. Yeah, I need to redo the naming of these functions eventually. Let's see. Get position. Then we want the forward vector, and then we want the amount. And let's try that. Okay, that is super, super, super fast. We of course need to add this time step. All right. As you can see here, it actually works as intended. Then we will have horizontal movement and implement that. And we will have let's do a g vector m right vector. Maybe we just want let's see, camera. Let's test it out with the camera's own right vector, because I think it will be wrong, but we might just see what happens. Move horizontal -20, and then get the time step and okay. It will actually work, it seems, even though if we, yeah, right now we can walk outside the different stuff because we have not coupled the mesh and the transform data and everything for But yeah, as you can see, we're now able to create a camera. And move it around as I do for a player. There's no jump or anything right now, but we will handle that in terms of physics. Great stuff. So the next thing is that we would like to be able to since we set our position for the transform, we would like let's just do it in a more proper way. So we do movement equal to position transform position dot x and then the last component is 0. Load float store float free. New position, let's say that, call it that. And then we want to store the m transform dot position, and we want a new position to be set here. And we of course want the reference to that. And we want to vector add camera offset, and then our new position here, camera offset. Yeah, we could do like this instead of storing it as a vector. Let's see, this should work the same. Well, it doesn't for some reason. Let's see. Oh well, this strafing doesn't work, of course. Let's see. Does it work entirely? Yeah, it does work entirely on that axis. It's because I kind of combined it with the old methods. Let's see. Instead of that, we do the right vector. And we do like that, I think. In terms of rotation. Yeah, everything works. Meaning that our camera now follows our player character controller position. Yeah, the next thing is to couple the bounding volumes and the mesh. Yeah, we need to do some decoupling here. We could do some start to migrate it. A player controller should come with a bounding volume as well as a transform. Bounding sphere. And on our on create, we bounding and physics is equal to the information given here. And the bounding volume radius is going to be hard-coded for now. We of course also want to update the bounding sphere center is equal to let's just do the same here. Store flow 3, or rather load float 3. Let's see. Yeah. Let's try that for now. Bounding sphere center is equal to that. There we go. We create a new bounding volume. The temp sphere. Is created. Up here, it's fine. And then we not inside the particles. Let's see, dynamic objects. Maybe. Then we update the end of physics. Let's not put it there. Let's put it after the player controller update. Player controller stuff. And our player controller will have an inline G vector get position, which will be our transform position, which we return. Well, math load float 3 position referenced. Oh well, it takes a float 3. Well, return a copy of that. Well, it doesn't really work, does it? Oh, of course, we do not want to add one. That's why. Update debug visual. How does that work? Offset. Yeah, so we need the offset here. Yeah, we want to offset by the, let's see, offset by the lines plus the dynamic bounding box system size. we still set it to blue. All right, as you can see, our bounding volume gets shifted around. Great stuff. Great stuff. Do we actually update the radius? We could do an inline float get bounding radius, just in case we change it for some reason. Bounding sphere. Huh? Oh well. Radius. Yeah, it's not a lot of yeah, we definitely want to swap these things around. I mean, we could update debug visual sphere. And instead do radius here. Let's do something like radius, radius, radius. Too many initializer values. For now, we will do it inside here. Let's see, and then we change this to the radius. Actually, we just grab it instead of assigning it to something and grab a copy of it. Great stuff. We have our bounding volumes here, moving around. Bounding volume update debugging. Let's add it like that. Then we want to update the local transform. So our game object here, number 6, m transforms, m game objects, number 6, the transform, player transform update for the mesh. Instead, we could do something like player controller inline object transform. And we copy it over. Get the transform and return the transform itself. And then we set it to the character controller. Get transformed. This will definitely mess up something. Will it? Let's see. Oh yeah, we do not update it. But we could. Let's see. I'm not reading the code. There we go. Now we will update it. It will probably just disappear. All right. Then we want to do a player controller private method. Recalculate transform. Or m transform dot matrix dot last row. Let's set it to rm transform dot position dot x and so forth. Let's try that. I'm not sure the translation will be accepted in this part of the matrix. I can't remember if I ended up being a row major, even though it's column major in memory. Yeah, definitely not working. So we could do the last one, or the first one is equal to that, then the, or rather, first one and then the last component, which corresponds to row major, then we get the C. or rather the Y, and then we get the C. There we go. I think this will be more correct. Then we will, let's see, expected a declaration. Oops. And perhaps we added one too many of those. Let's see. Do we get the expected result? That we do. So we now have total translation of the heart. Yeah. One thing I would like to test something out in the swap chain. I disabled screen tearing, meaning that we vsync everything. I just wanted to see how our performance was in nsync, rather. Okay, we need to transfer the files. Let me just do that. So we need to transfer models and textures and put it into the release build here. Oops, I wasn't going to check the actual allocations and so forth. I was just gonna check. Yeah, so we haven't optimized for any thing yet. Let's see. So we can actually achieve sometimes up to 3000 frames per second. Am I not allowed to? For some reason that doesn't work right now. I don't know why. Am I not allowed to? Okay, it won't lift off anymore. Huh? It won't lift off anymore. Did I change something? I mean, weren't it supposed to fly off here? Well, it does. Am I just pushing the wrong button or? Nah. Well, the force isn't great enough for some reason. Okay. Yeah, the object is really heavy, it seems. Maybe I changed the mass somewhere. Or the dampening. Yeah, I don't know. Alright. So far so good. We are now not only moving. Alright. I definitely need to. Well, we can still move the player controller, but yeah, and for some reason when oh yeah, that's because I don't know. Anyway, so the last parts are some physics collisions, and then we can move onwards to something else, which is great. I'm gonna do a break here. The YouTube video ended up being 2 hours, so I think we achieved all that we wanted. We got the player controls set up. We um, um, bound the bounding volume to, maybe we want to store the information actually. Maybe we want to, whenever we update like this, maybe we want to set the box. And just copy it over. Yeah, we could do that. But I swear, it's the last thing that we will ever do. Not ever, but inline bounding. Yeah. Reference. Or nah. Let's just copy it. Get bounding volume. Then we can definitely update the bounding sphere itself in terms of the system on the outside. We copy the information so that now whenever we test for collisions, we could do that. I don't know if we need to do that. Maybe we want some. Maybe we want something entirely different. I would think that we'd want some character-specific collision handling. Yeah. Since it will not be coupled to a physics system. Yeah, anyway, I'll contemplate that. Between this and the other video, just know that you can copy the maybe we want, for instance, to be able to shoot something at the player and let physics act upon it. Problem is, it's not really coupled to the physics system and would require a physics component anyway. Yeah, and this also could be changed so that we here segment, maybe segment into player, bounding, volumes, and other dynamics. Yeah, we will definitely do some restructuring as we go along. But yeah, hopefully you found some of this helpful, insightful, funny, or something else entirely. um, Feel free to support the channel by either commenting, liking, or subscribing, following on Twitch, or even using the Buy Me a Coffee link. Hopefully I'll be seeing you